In this session, we will discuss the stock removal cycle. In the previous sessions, we discussed the finish machining programs. But that is a line program. Now, we use CAN cycles in our programs. Let's start the discussion of the stock removal cycle for OD turning. This is the raw material. In this raw material, we will create this type of component. For this component creation purpose, we have to do two types of programs. The first one is roughing. Second one finishing. Why are we using roughing? We are creating this kind of piece in this raw material. In a single pass, is it possible to create that shape? It is not possible. Hence, we remove the material layer by layer. That is the roughing. We can create a line program for this shape. It takes a lot of time. Suppose we are using the CAN cycles in the program. Compared to the line program, it takes less time. For program creation purposes, first, we will require the drawing. This is the drawing of our component. We will check the component drawing. In this component, we have the chamfer, radius, and taper. This is called the profile. Now we will mention the points of the profile. Where our points start? Our points start at WCS. This is our WCS. The WCS point is P1. Next, the radius starts point. That point is P2. The radius endpoint is P3. The next point is P4. The taper starting point is P5. The taper endpoint is P6. Next, the radius endpoint is P7. The next point is P8. The next point is P9. That is chamfer's endpoint. The chamfer's starting point we don't mention, because we are using the CHR concept for chamfers. Next points are P10, P11, P12. These are the points of the profile. Now, we will discuss the values of these points. The P1 point value is X0, Z0. Next, P2 point value. In the P2 point, we don't know the diameter value. We discussed this in previous sessions. The diameter value is how to calculate. This is our radius value. It is converted into diameter. Remove these 5 from the radius endpoint diameter. The radius endpoint diameter value is 25. 25 minus 5 equals 20. It is the P2 point diameter value. P2 value is X20, Z0. Next, P3 point value is X25, Z minus 2.5, CR equals 2.5. Next, P4 point. That point value is X25, Z minus 20. 25 is the diameter, and minus 20 is the length. Next, P5 point. This point value is X35, Z minus 20. 35 is the starting diameter of the taper. Next, P6 point. That point value is X60, Z minus 40. 60 is the ending diameter of the taper, and minus 40 is the taper ending length. The P6 point is the taper endpoint and radius starting point. Next, P7 point. That point value is X70, Z minus 45, CR equals 5. 70 is the ending diameter of the radius, and minus 45 is the radius ending length. Next, P8 point. That point value is X70, Z minus 65. Next, P9 point. For chamfer creating purposes, we are using the CHR method. That point value is X90, CHR equals 3. At this point, we don't require Z value. Next, P10 point. That point value is X90, Z minus 80. Next point is P11. That point value is X100, Z minus 80. 100 is the final diameter of the component. Last, P12 point. This point value is X100, Z minus 100. Now, we will add these points to the motion commands. The first point motion is linear motion with slow feed. That motion code is G01. From P1 to P2 is also linear motion, code is G01. From P2 to P3 is a circular motion in the anti-clockwise direction. That motion code is G03. From P4 to P6 is linear motion. Code is G01. Next, the circular motion from P6 to P7 is in the anti-clockwise direction. That motion code is G03. The next point's motions are linear motions. Code is G01. Next, check the safety point of the workpiece. This is the safety point. The safety point value is X102, Z2. These values are shaper values. Our program structure is a header, shaper, and footer. That is the previous program structure. But now we are writing the stock removal cycle program. So, in this case, we need to create two programs. 1. Main program file, MPF. 2. Subprogram file, SPF. In the MPF, we will write the header, stock removal cycle, and footer. In the SPF, we will write the only shaper values. We already know the shaper values. Next, move on to the software. After going to the software, first, we create a subprogram and write the shape values. Next, we create the main program and write the header, cycle, and footer. Let's move on to the software. Double-click on the software. Select the machine and start the simulator. Next, adjust the speed override and feed override. The machine required a reference. Click on X plus and Z plus. Next, go to the Program Manager for new program creation purposes. Click on the New. First, we will create the subprogram. Write the program name is odprofile.spf. Click on OK. The new file is opened. In this file, we write the shaper values. First value G01, X0, Z0. Next, G01, X20, Z0. Next, G03, X25, Z-2.5. CR equals 2.5. Next, G01, X25, Z-20. Next, G01, X35, Z-20. Next, G01, X60, Z-40. Next, G03, X70, Z-45. CR equals 5. Next, G01, X70, Z-65. Next, G01, X90. CHR equals 3. Next, G01, X90, Z-80. Next, G01, X100, Z-80. Next, G01, X100, Z-100. We have an M code to finish this program. That's it, M17. M17 is the subprogram endcode. Next, go to the Program Manager for MPF program creation purpose. Click on New. Write the program name is odcycle.mpf. Click on OK. The new file is open. In this file, we write the header, stock removal cycle, and footer. Starting with the header. G90. Absolute dimensioning. G71. Program data in mm. G18. ZX working plane. G95. Feed in millimeter per minute. G64. The continuous path on. G40. Tool radius compensation cancel. Next, G75. X0. Z0. It means, return to the home position. Next, activate the tool. T01. D1. M06. Automatic tool change at home position. Next, activate the spindle. G96. Constant cutting speed on. M03. Spindle clockwise direction. S350. Cutting speed. LIMS equals 2000. Maximum RPM. Next, safety point. G00. X102. Z2. Next, M08. Coolant on. Now, we add the stock removal cycle. That cycle is available in the turn option on the horizontal keys. Click on the turn. Go to vertical keys. These are the CAN cycles. Click on the stock removal cycle. The cycle is open. This is the cycle 95. These are the parameters available in this cycle. Now we observe one thing. Whenever we scroll the parameters, the instruction line is above the parameters changing, with which we can easily understand what type of parameter we are working. As well as some parameters, graphical images also change. Both of these things give the idea. What are the parameters we are working on? Our first parameter is NPP. See the instruction line here, that is the name of the contour subroutine. So simply the controller is asking, what is the subprogram name or contour name? Contour means profile. Our subprogram name is OD profile. That name we will write here. There is no need to write .spf here, because .spf is a file format. Go to the next parameter. That is MID. See the instruction line. That is the feed depth without a sign. Also, see the graphical image. Here it is showing the passes. This the pass thickness, which means the controller is asking about the depth of cut value. Based on our tool nose radius, we will take the 1.5. So, we will write the 1.5 here. After that, we have three parameters that are interlinked. They are FALZ, FALX, FAL. The FALZ, see the instruction line, which is the finishing allowance along the longitudinal axis. Longitudinal means Z-axis. Next, FALX. See the instruction line, which is the finishing allowance along the facing axis. Facing axis means X-axis. And observe the graphic image. Next, FAL. See the instruction line, that is the finishing allowance suitable contour. It means allowance in both axes. What is the allowance? Allowance means stock. Why are we maintain the stock? For finishing operation purposes we maintain the stock. We are going to the FAL. We are maintaining the stock for the contour. 0.2. Go to the next parameter. That is FF1. It means feed rate for roughing. For roughing operation, we will maintain the 0.2 feed rate. Next parameter is FF2. It means feed rate for plunging into relief cuts. We don't write anything here. Next parameter is FF3. It means feed rate for finishing. For finishing operations, we will maintain the 0.1 feed rate. Go to the vary parameter. Vary means machining types. This parameter has 12 values in the 1 to 12 range. We can change the parameter value with the select button. That button is available here. Now, we will discuss them one by one. Using this button, we will change from 9 to 1. Now, we see the vary one. Go to the graph image. This blue is a required profile. But in this graph, the tool path did not touch the final profile. So, this tool path is leaving on finish allowance. This profile is an outer diameter profile with the axial direction. Operation number 1 means we will do the OD rough turning operation with the axial direction. Change the operation number. See the graph image. This is also an OD rough turning operation. But this is the radial direction. The previous one is the axial direction. Change the operation number. This is the internal rough turning operation with the axial direction. Go to the number 4. This is also internal rough turning. But this is the radial direction. Go to the number 5. See the graph image. This is the final pass of the OD finishing operation from bottom to top. Next, go to the number 6. See the graph image. This is the final pass of the OD finishing operation from top to bottom. Go to the number 7. See the graph image. This is the final pass of the ID finishing operation from top to bottom. Next, go to the number 8. This is also an ID finishing operation with radial direction. Go to the number 9. This is the OD roughing and finishing operation. See the graph image. This green line is roughing. And blue is matched to one green line, that is the finishing. This is the OD roughing and finishing operation with axial direction. Next, 10. This is also OD roughing and finishing operation. See the graph image. But this is the radial axis. Next, 11. This is the ID roughing and finishing operation. This is the axial axis. Next, 12. This is also ID roughing and finishing operation with radial axis. So we will move to parameter number 9. Because we will complete the total profile with one tool. Parameter 9 is OD roughing and finishing operation. These two parameters are used for chip breaking. In machining time, whenever we require the chip breaking, that time we will activate these two parameters and based on the materials. DT means dwell time in seconds. For holding the tool for chip breaking. DAM means path for roughing intercepted chip breaking. Means after how much of the length holds the tool some time. We don't require these two values. The last parameter is VRT. It means retract path for contour with incremental. We will write 2 here. After each pass, the tool will retract the 2 mm in both axes. Go to the first parameter. This is the subprogram name. Next one is the depth of cut for each pass. Next, finishing allowance for the contour. Next, feed rate for roughing and finishing. This is the operation type. OD roughing and finishing operation. Last one is the retract path. Now, we will click on the OK. Cycle is added to the program. Let's change any parameter on the cycle. We will move on the cycle with arrow keys. After that, click on the recompile. We can change the parameters and click on OK. After the cycle. Now, we will write the footer. Next, G00. X102. Z2. Next, spindle stop and coolant off. M05 and M09. Next, G75. X0. Z0. M30. Program end and reset. Click on the renumber. Blocks are provided with the sequence numbers. Go to the offset and check the tool. Next, go to the program. Now, go to the simulation. Activate the auto mode. Next, click on the cycle start. This is the tool path of our program. Blue color is the cutting path line and red color is the retract path line. Click on the Delete window. Now, we will go through the material simulation. Go to the More. Click Material Removal. Add the raw material length and diameter. Our raw material length is 100 and diameter is 100. Click on Save. Adjust the raw material in the center of the controller display. Click on Cycle Start. OD stock removal cycle is completed.